Some of you guys sound like you have a pretty good background in Spark, so this is not going to be quite as abstract, a little bit more of just a direct business application. I'm actually pretty new to big data. In a lot of ways, what I did with Spark is not really big data, so much as taking advantage of distributed computing. So who am I? Start off in a little intro. My background, like I said, I'm not a big data guy. I am a systems engineer. Done some web development stuff, do DevOps, CI/CD stuff for our company, and Python's really my bailiwick. That's where I reside most of the time. It's not Scala, it's not Java, and I work for a little company called Square 2 Financial. I don't know if any of you guys have heard of us. We are a leader in the asset recovery business. So make sure you pay your bills. But you know, we try to approach it with a little bit of a different attitude, and we take a lot of pride in that. You know, technology helps us do what we do really well, and that's important. So I get to the business case because we are actually in a very highly regulated industry. You know, it used to be the case that somebody could go to a bank and buy somebody's credit card debt and show up at their doorstep with a baseball bat, but that has gone away. And so now we really lean heavily on technology to remain compliant, which is kind of where this came from. Earlier this year, one of the regulatory agencies came down on the industry and told the industry, you are terrible at managing your data, specifically your media. Now, if we have a customer that enters our system, we have to prove that their debt is real. We have to somehow find a way of validating that, and the way we do it is media. It's a PDF, it's a statement that shows that you paid it, some form of proof that way. Otherwise, we can't do anything with it. If you tell us, hey, you know, you're full of it, we have to go walk in, and that's no good. So this was a really quick thing too, by the way. This happened in a hurry, and we had a couple of months to figure it out. It was get real or get fined. Luckily, Binder's full of data. That's a little Mitt Romney joke you guys appreciate, especially in the political year. But we are fortunate that we do have mountains and mountains and mountains of documents. Most of them are PDFs. Some of those come to us in other formats, but we also have not been very good about managing them. They mostly reside just on a NAS with an Oracle table that tells us where they are for all of our customers. We've been trying to get better about using different tools we have. We have Alfresco in-house as well, but the tool we actually use is a legacy tool. It's 2003 Windows Server, houses the application. It's called Hummingbird. I don't know if any of you guys have been around long enough to know, but it's pretty terrible. And so it was kind of a wake-up call. It was a splash in the face for us to figure this out. And I don't know why they chose me, by the way. I think it's just because I'm always digging into new things. They're like, hey, you can go figure it out. So I'm like, great, awesome. Sounds perfect. So the first thing I needed to figure out right away was, well, again, most of this is in PDFs. I needed to figure out how to get the text out. The second thing I needed to do in a hurry, and there is a validation piece of it, which is we just use straight pattern matching for, but the big piece of it was we needed to classify the text as a certain type, because there was a specific media type that we needed to do, or that we needed to prove we had for every customer to go forward. Tesseract page, yeah. So we ended up using Tesseract. I hope I don't blow through too many slides too fast for you guys. Feel free to hop in with questions anyway. But right away, I figured out PDFs are terrible. They're a horrible, horrible file format. I mean, they're awesome at the same time, but they really are challenging. And the reason why is because you can really do anything you want with it. There's no standards. You can just take an image and slap it in there. You can take text and slap it in there. You can scan a document. You can take a document that was created by Adobe It's fantastic in its shape, and some of you may know this. And you can scan it 1,000 times, and it comes in as a scan of a scan of a scan of a scan, and it's just a PDF with an image, right? Only it's basically black, and it's just awful. So right away, I started looking at OCR technologies. What I found pretty quickly is that most OCR technologies are all or none. Sort of take a look if you can get text out, or if you can look in the metadata and even determine that there's no indicator, like a font tag or something of that nature, that would say, yes, there's text here. You just assume that everything that's in it is an image, and you go ahead and pass it through OCR. And most OCR as well, what it wants to do is then translate that PDF into an image and then pass it through OCR. You know, Tesseract is, again, it's the great example that everybody's familiar with because it's open source and available. And it doesn't read PDFs natively. You have to figure out a way to give it that. So again, it's very much all or none. If you can't get text, go ahead, pass it through Tesseract, turn it into an image, pass it through. But that's a problem because there's really valuable information in those inline images. A lot of times they'll put customer information into an inline image, not to mention the fact that sometimes you will have an entire document that is a scan that still has something like a font tag, or you'll get a mix where a page of somebody's statement is scanned in because somebody at Bank of America screwed up and didn't know what to do, but the first page is really good. So we really needed to figure out how on earth we're going to be able to get at all of that, and that was hard. The second thing that we realized right away was that machine learning was really the road for us to go for classification. It was going to let us do it in a big data kind of way. Even though we're not necessarily doing big data, it was how do we not know what's actually in there and classify it. So NLP seemed pretty intuitive. You know, tokenize the words, vectorize them if you can, and figure out the right algorithm to classify. You know, as simple as that. It's a multi-class classification problem, if you guys are familiar. Then the last thing we figured out really quickly is that scaling is hard. And we figured this out, again, Python's my background, so the way I started and when I approached this was I set up my own sort of distributed system with just Flask, using REST APIs to do the messaging between everything, and some MongoDB to do caching for the data. This was really terrible. It was a lot of fun, and I learned a lot, but again, it was awful, and it fell apart and just tilted all the time. I used NLTK, which is a well-known Python library for doing natural language analysis, and then scikit-learn, and started learning a lot more about the different algorithms. Stochastic gradient descent fit the use case really well and gave us really performant results. But again, the scaling is a hard problem. And you know, as our previous speaker mentioned with Mesos, is it allows you to take full advantage of your compute resources and even oversubscribe. Well, we had the opposite problem, which is that there was a lot of time where nodes were just doing absolutely nothing. We had you know, manual kind of coded information or hash tables to try to manage what was being used at any given time. And like I say, it had bad news written all over it. It did work, but it was a constant management problem. So some of our senior leadership asked me if I had thought about Hadoop. It's like, oh sure, everybody's thought of Hadoop, but it's you know, it's not easy, and I'm not sure. They gave me like 8 weeks left to finish this out and make sure that it was stable. And I'm like, well, I don't know if I can stand up a Hadoop cluster in 8 weeks' time on premise. So I was a little bit nervous about it, but I got pushed. I think there was some other reasons that they wanted Hadoop in the door. And so I said, okay, and jumped on Spark and kind of went for it. So as we grew with Hadoop, and Spark, we learned a lot of different lessons. One of the things that was kind of nice is coming into Scala land, which was new for me. And I'd written a little bit of Java, but it wasn't, like I say, my bailiwick. And working with a lot of other people in the Hadoop world, they said, have you thought about Apache Tika? And in fact, we're a Hortonworks distribution user. And our sales engineer, he mentioned he had done something very similar using Apache Tika. And so, okay, let's take a look at what that is. Oh, Apache Tika is the answer to a lot of the world's problems, or at least mine. And it is really awesome. It's really powerful. And the reason why is because it does parsing, auto-detect parsing. So it can tell you what the document is based on file format, and then it can take a look at the metadata and tell you what it can get out of it. Because it's Java, it plays really nicely with Scala, and that was the direction I went for working with Spark. Was not Java, but Scala. I mean, I think most people would appreciate that, but it was a lot more Pythonic and natural for me. And then the functional paradigm was just a boost. It was a nerd reason to want to do it. Like, okay, that's great. So then the other advantage of using Spark was, and at first it was kind of a risk, was jumping into the ML11 ML APIs. It was a risk because I didn't know if I would get the same results as I did out of scikit-learn. And in fact, I haven't been able to. Lo and behold, there is a wrapper, Sparkit-learn, that I totally missed, and it's hard to go back in time. But the APIs are actually really beneficial because they let you work within Spark in a very natural way too. MLlib with RDDs and Spark ML for data frames, and data frames are really performant and really nice. But the best piece of all was that the distributed computing through Yarn makes it really easy to scale your compute across a lot of resources. So OCR is super compute heavy, and it remains one of our biggest challenges in the business in making that fast and getting the data out of the texts so that we can actually use it and monetize it. So having Yarn available there and being able to grow the cluster elastically is, it's awesome. It's really powerful. So it's been a huge boon for us. So data frames were what we kind of settled on, and it took me a lot of time playing around with RDDs, doing modeling with RDDs instead first. And this was in part because one of the mentors I had to lean on was much more familiar with RDDs. Data frames aren't old, but they aren't new. They've been around long enough that there's, again, in this world, everything goes so fast that it seems like something I should have grabbed on first, but I spent a lot of time playing with RDDs instead. When I found data frames, it was like, oh, yeah, I'll have this done next week, because it was that much more powerful. So if none of you have played around with data frames, they're fantastic. Instead of writing map functions or lambda functions, though, you're writing a lot of UDFs, and which isn't always the best practice, but it works. So you can still write procedural logic, and it distributes the work for you. You don't have to think about it in a functional sense if you don't want to, though you still can. They're also very fast. This is a fancy chart that says I'm right. And it is easy to build. The API gives you some just amazing tools out of the box for you to work with that basically make you feel like you can just import success. As an example, this is a UDF that we did for text extraction. So there's a lot going on here. These are open source classes from Apache Tika, from the jar. And as you can see, I don't know if you guys can see, my eyes are not great, but this function literal from Scala. So it's nice to write anonymous functions and very powerful in that way. So it's got a couple of things here. So it's got the parser, handler, body content handler. There's your Tesseract OCR config, your PDF parser config, all these different things. you pass it the file and it does the work for you. So it really is like importing success. And then declaring the UDF. But then on the data frames, this was the greatest win for us because we had these huge sets of data that were coming in, and we could essentially just take what was a base64 encoded string that was the document, and because it was coming in as JSON objects. That was part of our architectural design from the get-go. And we could on base64 and then send the thing just straight through, and it was fantastic. Right there, and you can just drop the old columns if you want. So it's nice to have this row type sensibility about it. I'm not an ETLer, but I've worked with a lot of ETLers, and they really appreciated that. That just made intuitive sense to them, being able to write code that allowed them to do that in a powerful way. So this is a huge win for us. And what's really cool too is to watch it happen. You will see we'll send 40,000 documents through at a time, and you can watch in the Spark UI, it will go and send it all out to the different executors, and you can take a look at what's happening. You can, and we have gotten to the point too, because Tesseract is an interesting beast in that it's somewhat single-threaded, and once it will only use one core at a time. It won't parallelize across a CPU. So we were able to fine-tune within Spark when we were submitting to the driver to say, okay, use 20 nodes or 20 executors, and then use 6 cores. So being able to specify that meant that at any given time, any one of the nodes was fully occupied, usually with OCRing, or at least the job of running the transformation, the Spark transformation that we had in there, this being the most compute heavy piece of it. So it was really cool to be able to watch that, and you can actually see certain documents will go out, and they could be big, they could be 2 MB file, and it'll go in 34 milliseconds, or it could be 500 kilobytes and it'll take 35 minutes. And then you can go back and you can take a look at those actual files, and you can see why what's happening is happening, because the 500 kilobyte file is just black with maybe some highlighted white text, and you have no idea what happened. Somebody reversed the scan or something, and it's just weird stuff. But it's pretty cool. It's a pretty powerful tool. So we were very pleased with that. The other thing, the API for building a pipeline, if any of you guys have played with this is the Spark ML version of building a pipeline. And this was a really powerful concept for us too, because we could go and we could build a model. Now, obviously you have to figure out how to get your data into the data frame and labeled appropriately, but it's so simple to declare these different data frames and just build a pipeline where you're declaring what the input column is and what the output column is, put it all together, and then on the other side, what you can't see in my code is, I have the data that comes in, we pass it through Apache Tika and it OCRs it, and then you just have model transform. And that is so fast, pretty awesome, and works great. So you can just have your model loaded somewhere in HDFS, and it pulls it up at the time of run, and you pass it all through, and that was really cool. Instead of, as I mentioned, trying to manage the data flow through scikit-learn algorithms that I had built before, this was a godsend. So it really did make my life much easier. Spark is simple, yet not. Oh, actually, I did include it. I couldn't remember if I included it. So that's it, right there. So that's loading your model and then running it across your data frame with predictions is obviously the data frame that I create with it. It's got everything to begin with, and I pass it through and it plunks out very nicely. The API gives you a lot of different things that you want to have. It gives you, obviously all the transformations that you had inside of there. So you tokenize your words, it gives you a vector or an array of those tokens, and then TF-IDF vector, and then it gives you actually, we were using naive Bayes, which seems simplistic, and in a lot of cases, some people would say not even really machine learning, kind of on that edge of just doing big stats. But it does output a probability array too, which you can use to determine whether or not, oh look, it said, yes, this class was the most likely, but it was still only 50% sure. So you can say, that's not high enough for us to be sure that that's what we wanted to do. So again, it lets us go very fast and power through, just munch this data in a really big distributed context. One of the interesting changes, though, we have gotten to is reading and writing directly from Oracle. Instead of using HDFS at all, we are writing down our final data product into HDFS, into a Hive table, and then doing a little bit to get it into a properly formatted Hive table where we like where it is and it rests, but we're not really doing anything with it. So that's why I say we're not necessarily doing big data as much as leaning on Yarn to do distributed computing in a way that we couldn't do ourselves before. It's pretty cool. So, like I say, it's just that easy.
Thank you.
Yeah.
Questions? Any questions?
Yeah, could you just go through a brief process of how you would use this in your job or your company's work?
Yeah. So I actually wrote a little front-end API that, actually I'll go back a step. Right now it is sitting in a state that's not the most usable. We are kind of developing out a Spark streaming model for it too. And I like that a little bit better, and I'll talk to that a little bit better, because what the front end does is submit messages. We're just listening on a socket, because we're not sending big messages across. You know, for us in our Oracle database, it's account IDs is what we would do. So somebody might come along and submit a list of 1,000 account IDs. And so we parse out those 1,000 account IDs, send them in as a list as a D string. And it uses those to go and then run the JDBC call back to the Oracle database. And then from there, it basically lives and imports all the data, all of the documents. And so that was a little bit of a disingenuous example of Apache Tika too, because we're using, instead of byte arrays, now we're using file input. So it just goes and reads from the data that it gets from the Oracle database. One of the columns is a file path.
So does it just give you a big document dump, or does it actually filter out the noise and just give the human what they need to do their job better? Just the information they need, yeah. Because that's where we're finding the trick is.
No, so the write back, so we actually have an application that we built in-house too. It's sort of a CRM. It's a little crudish, but it does the trick for us. And in our industry, it actually really helps us because we are so regulated. It gives us this closed loop network advantage. Point being that because we control that application and we control the database, we can make writes down that are meaningful within that application. So in comes the data and does what it does and munches. And as I say, it writes a full data product down in HDFS if we want to analyze later, which we probably should and could do some amazing things with. But the meaningful part of it is just it just uses JDBC to write right back down into Oracle. And that is just some specific flags that are about the media. Every piece of media we have has an ID. So those pieces of media in that database now are correlated back to accounts, and we have sort of, quote unquote, set the flags we need to set. So then when users, lawyers, or whomever are going through and trying to say like, hey, does John Smith have a such and such piece of data, that flag has been set in Oracle, and they can see that right there in the UI.
So your model classification is determining that flag?
Yes. And there are others, like I said, there's some pattern matching as well that does write backs, you know, for different things, like, oh, we found John Smith's name within this text too. So there are other things we're looking for, but the machine learning is the most important. That was the big one. We had it's the actual class that we had to find is called statement of use. So we have to prove that somebody actually used the account and one time paid on the credit card or what have you.
Have you used Spark SQL?
Yeah, just like using the SQL context. Is that what you mean?
Yeah, Spark. You are using Spark SQL. You're using Spark to access the database.
Oh, I see what you mean. Yeah, so interestingly, there is a way to access through JDBC to go and get it. It's a little finicky. At times, you can't like pass in a statement with a where clause like you could if you were just writing an application in Python is my favorite. So Python has a module that it lets you just pass in raw SQL statements, whether it's inserts, updates, deletes. So the JDBC API doesn't like that. It wants a table name. So you have to alias it. So, select star from table name where, blah, 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 put it in parentheses, and then alias it. So just call it whatever you want. So it really doesn't matter. Call it T, right, for a table. So as long as it has that, so it's alias, so it thinks it's looking for a table, it's fine. So you can do filtering like that. But what most people want to do in Spark with that sort of thing is pull in an entire table, because that's the point of it, is to have the entire table sitting in memory, and then you can do operations on it all you want, and it's very quick, because the I/O for memory is much faster. We don't have that luxury. Part of it is, as I was doing my research, I was telling people in the business, okay, we need nodes with a ton of RAM and a ton of compute. And they're like, oh yeah, well, this is what we're going to give you.
I've used Spark SQL for and credit shell, so you can't let the database do all that stuff for you. I just want to put it into one.
Oh yeah, for like pulling tables in?
They're actually doing the querying on the table itself and then, letting Spark. Let the database do that and then pull the results.
I see what you mean. So one thought, our DBAs really want to do a lot at the database layer. So they're like, oh, let us give you a materialized view, or let us give you a persistent table. And I'm like, that's great, but it's hard to do on demand. So, our customers upstairs, they're like, well, I don't know what account IDs I'm going to want run through tomorrow. And, I don't want to wait either. And, of course, the typical IT response is, well, too bad, you're going to have to wait. The one nice thing about doing it in Spark and figuring out that way is I can go back and tell them, well, good, you don't have to wait. So I figured out a way to do the filtering within, and it's, it's not hard, just tinker with it a little bit. Now you can do it kind of more on demand. But again, really the reason we went with Spark for a lot of it, instead of doing the data analysis in the database, was because of the OCR and how compute intensive that was.
Oh, no, not the data analysis, but actually the filtering of the data that brings back the analysis. Spark SQL is pretty nice for that, so you don't have to transfer so much data back and forth between the database to get it into memory and all those stuff. That's just the point.
And we're using the data frames API, so we're doing a lot of, the code base just looks like a ton of actions and one transformation at the end, or two actually, it's saves that are the transformations at the end. And so all those actions though basically are just declaring new data frames as they go. So all it's doing each point along the way is adding columns, dropping columns according to those data frame declarations, and as it executes that transformation at the end. So that's all. Data frame API is just SQL context. That's what it is. It's pretty cool. You can get things out of data frames if you want to, but mostly what we're doing is just adding columns and renaming columns as we go. But yeah, I like it.
So could you help me apply that to a real business knowledge process? So for example, Matt here owes Oracle $50,000, and Oracle hires your company to get as much of that as possible from Matt. What information do you need to do your job? I mean, I'm just kind of curious as to what the goals are, the processes are, so I can visualize it.
Right. So what we validate in terms of media, it doesn't really matter. It doesn't make us better at getting money out of him. It makes us compliant. So basically the CFPB, which is, oh God, I can't remember what it's called, Consumer Protections Bureau or something like that. They're there for you guys. And they have told us that we cannot sue a customer who has an ability to pay us but no willingness to pay us unless we have a document that says they have shown use before. We can prove that in court of law. So if we go to a judge and we say, Matt, owed this money and he's refusing to pay, we would like to levy a suit on him. We're going to say, show us that he used the account. And so we can produce that document though, and because now that's on the flag in our Oracle database, and our lawyers can see it when they're working Matt's account. They can go, oh, it's this document right here. Out of the thousands that Matt has, this is the one we can see right in the web UI for our tool. So we can go ask the IT folks, give us the document.
Thank you.
Yeah.
My understanding in the state of Colorado is that you don't have to justify or be compliant in any way to sue somebody for a debt. So what value is this bringing? Do you guys operate in other states where compliance is required?
We're in all 50. Yeah.
Okay.
And if that was true in Colorado before, I doubt it is as of 2 weeks ago when the CFPB published their.
Oh, no, it's still valid. They never can sue anyone for a synthetic debt.
Okay. Yeah. But I'm not the lawyer. I just give them useful technology. So, yeah.
Anything else? All right, well, thank you. I want to thank the speakers for ending exactly on time in each of their respective slots, and so now you can hang out until 8:45 or so before I'm going to kick you out. Does that work?
Yeah, thank you.
Oh, yeah.
Sorry, Matt, I didn't mean to
Somebody going to dinner with you?
Not you. No, I mean, you want to come to see
Yeah, I went to sit here.